do we objectively diagnose it and then effectively treat it. But this is exciting because we do in fact have a number of investigators now that are exploring many aspects of this one particular diagram, or this model. We can think of it as a model of CFS. So where are we at now with chronic fatigue syndrome? Well, I think we've actually come a long way. I think you would agree after that crash course in the biology of CFS that we do know a lot about it, a lot about the pathophysiology and the biology. We've also come a great deal farther in our education and in our awareness, what people think of CFS. Recently, the Centers for Disease Control has done some web surveys and some querying or polling of the provider population, and they have found that greater than 90% of providers have heard of CFS, they believe it exists, and they agree that it has a severe, profound effect on the quality of life of individuals affected with CFS. Interestingly though, less than 50% of them believe that treatment options are available, and even less than that, 25%, feel that there is enough information available to them in order to be able to diagnose CFS. And what providers want are the information for proper evaluation of individuals, and then tools to be able to objectively diagnose, and most importantly, the tools to be able to treat people with CFS. So while I think there's a lot of hope here, we've gotten over the hump of people not necessarily believing that it exists. It does appear that that we've come a long way, and on top of the fact that we know a lot about the biology, it should seem that diagnosis and treatment are just around the bend. I'm going to wrap up here by just giving you some information on where we hope to be able to get to with our accelerated research campaign. Right now, if you take CFS and put it into our current medical system, it really translates down to a reactive medical care system, where we come in to the doctor, we are sick, we get a diagnosis, and in the case of CFS, you can actually kind of put 24 of these diagnosis boxes or 25 of these diagnosis boxes up this curve. You maybe get some type of treatment, another diagnosis or a different diagnosis, another type of drug, another type of treatment again. So by the time you actually exit the healthcare system, you may still be without a diagnosis, and in fact your disease may be in a worse place than when you entered. You may be more sick. This is obviously a very costly system that is built on almost a trial and error process. Not very effective. It is a reactive medical care. I think that there is hope that change is occurring, or change is happening in CFS, that objective diagnostic measures will be available soon. And when I say objective diagnostic measures, what most providers need and can use to be objective is a blood test. And this is a recent demonstration of how blood can be used to subtype, and diagnose CFS. This is a work from Jonathan Kerr out of the UK, who actually used gene expression of blood, took blood, used gene expression. Remember, expression is the activity of the DNA. And this was expression of 88 genes, and with those 88 genes was actually able to come up with, find my pointer again, 7 subtypes or 7 types of CFS. So I've kind of, this is my old schematic. I should actually have CFS types 1, 2, 3, 4, 5, 6, 7, but I only have 1, 2, 3. What I think we will be able to get to using this type of genomic approach is the ability to objectively diagnose CFS and put people or type people. And the reason that that is important is because ultimately when you have objective diagnostics that's able to describe the disease at a molecular level, you can also customize intervention. When we end up with an objective diagnostic measure, what we will have is a more efficient medical care system. So we will have a diagnosis much more easily, and we will then be able to have the correct drug in order to be able to, instead of having a kind of a trial and error approach, the molecular profile will essentially help us, guide us into the right type of intervention or therapy, and then you exit the medical system more or less on a monitoring basis. Not cured, not perfectly healthy, but a heck of a lot better than that previous system where you were actually leaving much worse than when you came in. So the way forward is to ultimately have an early diagnosis or an early detection system for people that have CFS that can then be, people with CFS can then be typed or have some type of diagnostic or marker that would be able to group people into the respective types of molecular profiles that will allow more effective treatment. And this is not far off in the future. In fact, it's being done now with many types of chronic illnesses, such as hypertension, heart disease, depression, cholesterol. What we can do now is actually take blood tests, genomic profiles, molecular profiles, and customize treatment so that there is a much more effective response when you are on a particular type of drug. In order to be able to customize therapy, you need to be able to understand what is going on at the molecular level, at the DNA level, and we are now getting a much better handle on that with CFS. So objective diagnosis and effective interventions are possible, and we just have to figure out how to make that happen for CFS. Oops, should I go back? Okay, so now that about wraps up my portion of today's presentation. And it actually looks like we were able to hold on to almost everybody that joined us. We actually gained quite a number of people, and it looks like mostly everybody is happy. We have little happy faces here and there. There is so much information that I hope to be able to present to everybody over the next couple of months or over the next year.